Interview questions we are covering in this video are: what are some of the use cases of Kubernetes? What is the difference between Daemonset and Sidecar container? What is the difference between secret and config map? Why should I choose EKS, GKE, AKS rather than running self-managed Kubernetes on virtual machine? What feature would you add to these cloud-provided Kubernetes services? What is etcd? Is etcd specific to Kubernetes? How do I take backup of Kubernetes cluster? What is Kubernetes network policy? How is it different than service mesh? What is the difference between a load balancer service and ingress? What are some of the Kubernetes tools you have used? Tell me one thing you like and dislike about one of those tools. What are some of the Kubernetes security best practices? What is Kubernetes controller? What is Kubernetes operator? How is it different than controller? What use cases are not good with Kubernetes? What is Gitops? And can you explain the end-to-end Kubernetes application DevOps flow? This is a relatively long video with a lot of packed content, so I've given timestamp for your viewing convenience. For those of you who are new to the channel, my name is Raj. I'm a senior container and serverless architect at AWS. I'm also a best-selling published Udemy Pluralsight author, public speaker, and previously I was a distinguished cloud architect at Verizon. All right, let's get started. What are some of the use cases of Kubernetes? So one of the most popular use case is of course microservices. So you can give an example such as, let's say you have a 3-tier architecture running with presentation layer, application layer, database, and the code for presentation and application layer are running inside pod, and you expose the presentation layer pods with Kubernetes service or a load balancer ingress, and also the traffic between presentation layer and application layer is getting routed through a service or ingress. Now what about APIs? Because Kubernetes ingress or Kubernetes service doesn't provide all the features of an API. Maybe you want to bring in a Swagger file, maybe you want to have different API methods and other API functionality. So you can use Amazon API Gateway, but one trick thing to remember is API Gateway does not integrate directly with Amazon EKS. So API Gateway needs to send the traffic to a load balancer, either network or application load balancer, and then they will send the traffic to Amazon EKS. If you don't want to use this API Gateway to load balancer to Kubernetes design, you can also install an API management platform directly in Kubernetes. So let's say you can install Kong or Glue or other API management platforms such as MuleSoft in this Amazon EKS cluster, and then you create APIs on those API management platforms, and then those APIs can route the traffic to the pods in the same cluster or different clusters. So everyone will mention this microservices use case to the interviewer, but what about some of the other use cases? So you can run a lot of tools on Kubernetes. This is getting very popular. One example is you can run Jenkins on Kubernetes cluster. You can also run GitLab on Kubernetes. Currently, GitLab runners can run on top of Fargate, reducing cost and increasing efficiency even more. And another cool use case for Kubernetes is EMR on EKS. So EMR is the Elastic MapReduce service where you can run big data and analytics workload. Amazon EMR on EKS provides a deployment option for Amazon EMR that allows you to run open source big data frameworks on Amazon Elastic Kubernetes Service or EKS. With this option, you can focus on running analytics workload while Amazon EMR on EKS builds, configures, and manages containers for open source applications. So what are some of the advantages of this? You can use the same EKS cluster to run your other application code as well as EMR workload. And you can run EMR on Fargate. If you run EMR separately without EKS, you can only run it using EC2 instances, and that kind of increases the cost. But with EMR on Fargate, you optimize the cost. And the infrastructure teams can centrally manage a common computing platform to consolidate Amazon EMR with the other container-based applications. And as I described before, it is also cost-effective because you are using the same cluster as well as you can utilize Fargate. Okay, next question. What is the difference between Daemonset and Sidecar container? So Daemonset is used to ensure that some or all of your pods are scheduled and running on every single available node. This essentially runs a copy of the desired pod across all nodes. When a new node is added to a Kubernetes cluster, a new pod will be added to that newly attached node. One example of Daemonset will be ingress controller. So in this case, in this node, you will have a dedicated pod for that ingress. And a sidecar container is a container in the same pod that's loosely coupled to the main application container running within the same pod. So there is difference in IP address behavior because each pod will have a distinct IP address. So for Daemonset, each pod for the Daemonset will have its own separate IP. Whereas for the sidecar, it will share the IP address for the application container because they are in the same pod, but they will have different port address. So in this example, for the right pod, both the application container and sidecar container running within the same pod, application container is exposed with port 80, whereas sidecar container is exposed using port 1025. So what are some of the examples? So Daemonset examples could be ingress or Datadog. So for each node, Datadog will be collecting some data and sending it to Datadog. Another example of Daemonset is FluentD, FluentBit pods, where it will collect the logs and send it out. The sidecar example would be Twistlog container in AWS Fargate. Because there is no EC2 for you to manage in Fargate, Daemonsets are not possible. So if you need to use some sort of utility software such as Twistlog to scan, you need to use it as a sidecar configuration. Next question, what is the difference between secret and config map? So a config map is a Kubernetes object to store non-confidential data in key value pairs. It does not provide encryption. If you are familiar with Lambda, this is very similar to environment variables in Lambda. Whenever someone says Kubernetes object, that means you have to have a manifest file attached to it with a separate kind. So in this case, the kind is config map. The name of the config map is game-demo, and then it has some key value pair, such as player underscore initial underscore lives is 3, UI underscore properties underscore file name, and then there are some file-like keys such as game properties. And as with any other Kubernetes object, you have to deploy this using kubectl apply-f and the name of this config map file. So now when you define your application pod with the kind pod, you can refer to this config map under the environment section. Under value from, it is saying refer to the config map named game-demo and get the value for player underscore initial underscore lives. So in this case, it is going to fetch 3. Similarly, it is fetching the value of UI underscore properties underscore file underscore name. Config map is useful to keep your application code separate from your configuration. This lets you change the configuration easily depending on the environment, such as development, production, testing, and to dynamically change configuration at runtime. Secrets also saves key value pair, but as the name suggests, secrets is used to contain sensitive data such as password, token, keys, etc. By default, it is stored in etcd in a base64 encoded form. So you might think that, alright, so it is just encoded with base64, so you can always get the base64 encoded text and then decode it. Yes, that was true, but recently you can encrypt the secrets using application-specific KMS keys. So now it is not easy to decode those secrets unless you have access to that KMS key. So again, it is a Kubernetes object. So whenever we say Kubernetes object, that means it has to have a manifest with a separate kind. So kind for this is secret. And in this case, we are defining user underscore name and password. And you apply this file with kubectl apply-f, name of the file .yaml. You can also get the secret, kubectl get secret, and then name of the secret, in this case my secret, and this will be base64 encoded unless you are using KMS. And how do you use it in a pod? So in this case, under environment variable, you can see we are fetching the value from a secret named my secret, and we are fetching the value for the key username and the password. And there are different kinds of secret. This type opaque is the default kind. So you could skip that. If you want to dive deep, please look up different kinds of secret. But generally, interviewer is not going to ask you about different kinds of secret. So how do you encrypt secrets with KMS? You have to specify during EKS cluster creation time. This is the UI from the console. You can also do that in a CloudFormation, Terraform, or CLI. There is a minimal cost associated with it. If you want to dive deep on this, look up this blog that I have given in the screen. Next question, why should I choose EKS, GKE, and EKS rather than running Kubernetes on virtual machine? Basically, running and managing Kubernetes yourself on EC2 or other virtual machines. And what is one missing feature that you think should be built in EKS, GKE, AKS? So benefits of managed Kubernetes service, there are many. The main benefit is it provides highly available and scalable control plane. EKS control plane runs in 3 different availability zones. So even if one AZ goes down, your EKS cluster will still be up and running. If you are self-managing this, you are provisioning 3 EC2s in 3 different availability zones with proper auto-scaling group to run the control plane. Because even if the number of worker nodes goes from, let's say, 5 to 1,000, the Kubernetes control plane can scale and you don't have to pay extra for the control plane. Whereas if you self-manage, you need to increase the size of the EC2 where the control plane is running. You have to ensure it scales, the network input-output is proper, etc. Console and UI is always nice to spin up cluster and check some of the metrics. It provides one-click version upgrade. So Kubernetes provides frequent version update. So cloud provider will give you the capability to upgrade the Kubernetes versions without bringing the application down. So for EKS, it does it using managed node group. Cloud provider also gives you managed AMIs with up-to-date security patching. So in case there is a security vulnerability, AWS provides you with the latest AMI with a security patch, and with one click, you can upgrade all of those. It also provides easy installation of tools and add-ons. For example, for EKS, you can use Amazon VPC CNI to take advantage of multiple VPC features, as well as Amazon EBS CSI to use EBS as your persistent volume. And also it integrates with other services. We talked about EKS with EMR use case. Also EKS integrates with step functions and multiple other functions. And on the same line, interviewer might ask you what feature would you add to this cloud provided Kubernetes service to see that if you have really used the service or just saying stuff from theory. So for EKS, it's pretty simple because EKS provides their roadmap in an open source GitHub repository. So you could pick some of the features from either researching or we are working on it. I work with a lot of customers, and one of the features that I am looking to get added is the support metric server. So currently, if you have to use metric server, you have to install it after you provision your cluster and you have to maintain it. So if AWS does that for you, because metric server is used almost all applications, because to scale your applications in the pod, you have to specify CPU or memory and the limits. So all that is depending on the metric server. But as I said, go to this link and you can pick a couple features to keep in your mind to add. Next question, what is etcd? Is etcd only for Kubernetes? So etcd is a highly available and consistent open source key value store. So the consistent part is pretty self-explanatory. Whatever you write and update afterwards and then you fetch the value, it should always give you the most recent updated value rather than the previous inserted value. The highly available part, interviewer might ask you. So it is highly available because etcd runs in a leader worker cluster configuration. So even if one worker node goes down or even if the leader goes down, it has the capability to recover from that. For Kubernetes, it is used for saving cluster data. It saves Kubernetes cluster state data, configuration data, and metadata. For EKS, for each control plane, EKS runs a multi-node etcd cluster. So if you spin up multiple EKS cluster, it has dedicated etcd cluster for each one of those. And finally, etcd is not for Kubernetes only because it is open source. CoreOS Container Linux uses etcd. Uber internal app called M3 uses etcd. I'm confident that other companies using etcd for other purposes, they have not just said it publicly. Next question, how do I take backup of Kubernetes cluster? So first you have to specify what is there to backup. So there are two things to backup. One is Kubernetes objects and configurations stored in etcd, which is part of the control plane, and then the application data stored in persistent volumes in case your applications are stateful. For control plane, cloud providers take backup. It is possible to take backup using third-party tools, which we are going to go over in next slide. For the application data stored in persistent volumes, it can be backed up using native Kubernetes snapshot API. So there is no one-click option. So you have to schedule the snapshot APIs which you run and take the snapshot, save it in S3, and then you can restore it in case the cluster goes down. EBS can be backed up using EBS CSI driver. So this is one of the EKS add-on that you can install, and I have given the link in case you want to dive deeper. But preferably, you want to use tools to do all this for you, because this is quite a headache if you need to take snapshot, make sure they're up to date, and then restore. So there are multiple backup tools. Some of the popular ones are Portworx, Valero, and Kasten. Next question, what is Kubernetes network policy, and what is the difference of network policy with service mesh? As the name suggests, network policies can control the network traffic flow. So let's say you have these two namespaces, web server 1, web server 2, and they are both interacting with this database, and you only want the traffic to the database from web server 1. So you can achieve that using network policy. With network policy, you can specify that the pods running in the namespace database can only accept traffic from namespace web server 1. It is great for multi-tenant clusters. So this is an example Kubernetes network policy. You can specify ingress to select what incoming traffic can come into this pod. So in this case, we are accepting traffic from CIDR block this, and it is excluding this block within that CIDR block. You can also use namespace or pod labels. And you can also specify egress. One tricky thing to keep in mind that you need network policy agents for your network policies to be effective. By default, they are not installed. So CNI is installed in your Kubernetes cluster by default, but you have to install these network policy agents. Some of the open source network policy agents are Weaveworks, Calico, and Antria. So I have a separate network policy video going over what is CNI, what are the different network policies, along with a hands-on demo in a separate video. I'll give the link up top, so please check it out if interested. So what is the difference of network policy with service mesh? So as you could see, you could restrict the traffic with network policy using the IP addresses. So network policies can work on OSI layer 3, which is IP address, or 4, which is port. But service mesh cannot see IP address, so it works on layer 7. However, service mesh has additional features such as rate limiting, throttling, circuit breaker, proxy-to-proxy security, tracing, and more. So service mesh is getting pretty popular right now. So study service mesh separately. I have a separate video on what is service mesh. I'll give the link up top. Check it out if interested. Next question. This one is pretty important. What is the difference between a load balancer service and ingress? So let's start with Elastic Load Balancer service. With this kind of service, you can expose your pods with a load balancer, and all the pods needs to have the same label. But let's take a practical example. Let's say this particular gentleman want to run Batcave systems using Kubernetes. So you'll have different systems. So this load balancer will have a DNS, and you can track, you can map that DNS to a URL such as track-joker.com. And then if you want to monitor Batcave, you have another load balancer service with a different URL, and so on and so forth. But then the problem is you cannot have all these different services under the same URL. So ideally, you want to have batcave.com/trackjoker/monitor-batcave/order new batsuit. And if you want to achieve that with a traditional load balancer service, you have to have another load balancer sitting on top with a route 53 with batcave.com, and then you have to route traffic for different routes to this underlying load balancer. So it is costly to maintain this configuration because you are using a lot of load balancer. And by default, if you did not use this top load balancer, you cannot have the URL-based routing because you cannot use the same top-level domain URL. Also, there is maintenance overhead of managing all these separate services. They will be part of different deployments. So how to solve this problem? Well, ingress is the answer. Ingress exposes HTTP and HTTPS routes from outside the cluster to services within the cluster. And traffic routing is controlled by the rules defined in the ingress. So basically it supports path-based routing, and ingress is achieved with one single load balancer. So you can have the same top-level domain. It supports SSL. So you might think, what is the difference between this and the previous one? Because even in this one, the ingress is a load balancer, and that is routing traffic to the underneath services, even though these services are node port. And node port doesn't use a load balancer, and it is free of charge. So basically the cost will be less, but you might think it's still making two hops, one in ingress and another through this node port service. So the beauty is with ingress, you don't need these intermediate services. Ingress can register the pod IP address directly, and it can reach those pods without the intermediate services. So it is faster. So make sure you really understand ingress, because this is what is used in real world applications and not load balancer service. This is an excellent moment for you to click that like button and subscribe to this channel. Every like helps this video reach new viewers and help this channel grow. Also, if you are looking to learn Kubernetes, system design, serverless, CloudFormation, CDK, DevOps, Git, and GitHub, check out my highest rated and best-selling courses. I will give the link in the description. All my courses come with a 30-day money-back guarantee. If you don't like the content, you get your money back, no questions asked. This is an excellent way to support me and help this channel grow. All right, on to the next question. Next question, what are some of the Kubernetes tools you have used and like and dislike? So this like and dislike part is to see that if you have actually used those tools or just heard about them. So I'm going to go over some tips and tricks on this one. So whenever someone asks you about Kubernetes tools, think of the tools in different areas, and if you mention the interviewer tools for the different areas, interviewer will be impressed. So for example, you could say there are different areas of Kubernetes. For example, logging, I have used the tools FluentD, FluentBit. For monitoring, I have used Datadog, New Relic. For cost optimization, I have used KubeCost, Cloud Health. For storage, I have used Portworx or Valero. For security, I have used Aqua or Twistlock. And for DevOps, I have used Jenkins or GitLab. Also note that I have gave example for all these areas. So chances are you have not used all the tools for all these areas. So you could just mention one or two that you are comfortable in. So I made the color of this DevOps row golden because knowing DevOps with Kubernetes is golden and in super high demand. So make sure you know how to deploy to Kubernetes using at least one DevOps tool. And these are just name of some of the things I have used. If you have used other tools in these areas, feel free to mention it. So now let's go over one thing you like and dislike about one of the tools. So I'm going to use Jenkins because I have used Jenkins a lot. So some of the things I like about Jenkins is you can integrate with existing pipeline jobs. So if you already have a pipeline job which is deploying to EC2 or it is doing some unit testing, you can reuse all of those things with the Kubernetes because everything is controlled through either Jenkins file or DSL. Very easy to integrate. Jenkins is probably the most popular DevOps tools, and there are a large number of examples available. So if you are trying to do something, you can always look up and grab those Jenkins files. And Jenkins runs on Kubernetes itself. Some of the things I dislike about Jenkins is if you relied on third-party plugins, they sometimes can go out of date and can have security vulnerabilities. To navigate that, you have to develop plugins in your own company and then maintain them, which kind of adds the overhead. And you pay for the primary node even when it is idle. So basically, you always have to have the primary node of the Jenkins running. Either you run it on Kubernetes or EC2. You pay for it even if there are no Jenkins jobs running. This is different than cloud native DevOps tools such as AWS Code Pipeline, where you only pay per use. And this is from my experience. If you have some other pointers, make sure you study those before you go to the interview. Next question, what are some of the Kubernetes security best practices? So one best practice is create minimal images. As you reduce the image size by removing unnecessary packages, you also reduce the attack surface, and you achieve that using multi-stage builds to reduce the size. You should run static scan on repository and dynamic scan on pods for vulnerabilities. Use hardened AMIs or application machine image. Make sure you don't get confused between this static scan on repository and hardened AMIs, because in repository you save Docker container, and this hardened AMI is used to spin up those worker node EC2s. And the Docker containers run within a pod within those EC2s. And to make sure your EC2s are compliant, you run kubebench for CIS benchmark periodically on your node. Use network policy to control pod traffic. You can control traffic by IP address, label, or namespace. And also implement RBAC, which is role-based access control. Specify separate roles for separate groups, admin, developer, tester, etc. These are just few of the security best practices. There's a whole lot of them. These are the important ones. If you want to check out the whole list, check out this link I have given below. I also have a separate security best practices video. I'll give the link up top. Check it out if interested. So I combined the next two questions. What is Kubernetes controller? What is operator? And operator versus controller. So there is a lot of confusion around this. So let's get our concepts clear. So the core principle of Kubernetes is the current state of the cluster should match the desired state of the cluster. So it is done by a control loop. So this control loop observes what is the state of the current cluster and sees if there's any difference with the desired state and then act on it. So for example, if you have a deployment file with the replica specified as 3, and then one pod goes down, this control loop now observes that the desired state of the cluster, which is 3, deviated from the current state of the cluster, which is 2 pods, and then it is going to spin up the another pod. So controller is in charge of these control loops. It watches the state of each Kubernetes resource. So Kubernetes resource could be pod, service, etc. And it's specified by the kind field in manifest. If I go back to the previous screen, so in this case, the kind is deployment. And you'll have separate controllers for each of these kind field. It will initiate changes as needed to bring cluster state to match the desired state. For the previous example, where the kind is deployment, so the controller sees there's a difference, and then it talks to the API server, and that API server brings up another pod. In some cases, some controllers will interact with external state. For example, cluster autoscaling controller, which checks if the number of EC2s are matching the desired state. If not, it will talk with the cloud provider services and bring the current state matching the desired state. So now there are two different kinds of controller. Built-in controller. So this built-in controller monitors all the out-of-the-box resource, such as deployment, service, etc. The custom controllers monitors custom resources. So let's talk about custom resource. Let's say you have to deploy MySQL into multiple clusters. And to do that, you have to deploy multiple files. So for pod, service, stateful sets, custom configuration, etc. And this is just for one cluster. And if you have to do that for multiple clusters, this is a nightmare to deploy and maintain. So what you could do is, you could have a custom resource definition or CRD. This is an object. So anytime someone says a Kubernetes object, that means there has to be a manifest file with a separate kind. So the kind is custom resource definition, and then you can give a name. So I skipped some stuff in between because CRD is a lecture of its own. But in this case, I have put the name of the kind as MySQL cluster. And then you could have a separate manifest file where this kind is using this custom resource MySQL cluster. And it is saying it needs 3 replicas of this cluster. Note that this kind MySQL cluster is not a standard out-of-the-box Kubernetes resource. It is a custom resource. And another thing to note is, even though I'm just showing the manifest file, you have to create program to tell it what to do. So sometimes folks have misconception that if you use a custom resource definition, you don't have to do anything, everything gets solved. That's not true, because you need to tell Kubernetes what does this custom resource do. Only thing it does is you just do this thing one time, you write programs and merge all those different manifest files and do some extra stuff in your program. But once you do that once, then you can use this kind in multiple clusters. And you apply the manifest file for this custom MySQL cluster resource by running our regular kubectl apply command. So we talked about control loop for standard Kubernetes resources. But how about these custom resources? So this kind is MySQL cluster, and Kubernetes doesn't give you a controller for this kind. So for custom resources, you need to program the custom controller which is going to watch this custom resource MySQL cluster. So if the current state deviates from the desired state, it is going to act on it and bring it closer to the desired state. So operator has two components, CRD, custom resource definition, and custom controller. Together, they are called operator. So how to write operator? You can write operator using Kubernetes operator SDK and any programming language, but ideally you want to pick a programming language where there are a lot of examples available for this operator. So you can pick Go or Python. These are the two most popular ones. So next question, what use cases are not good with Kubernetes? So Kubernetes is amazing, but it does have some challenges. The setup is complex, it has steep knowledge curve, new Kubernetes version releases frequently, and you have to upgrade your cluster beyond a certain point because the cloud provided Kubernetes service don't support more than last 3 to 5 Kubernetes versions. It has challenging day-to operations, always evolving landscape, and it could be expensive if you don't know how to optimize it. So some use cases which are not suitable for Kubernetes are, let's say, batch processes. You can utilize that with Lambda, with cron expression, AWS batch, etc. You don't need to spin up a whole Kubernetes cluster to run some cron jobs. Simple microservices, you can use ALB or API gateway with EC2, Lambda, or even App Runner to run simple microservices. Event-driven applications utilize SQS, EventBridge, Amazon MQ, etc. rather than installing MQ or other event-driven softwares in Kubernetes. And last one is database. Always try to use managed service for database because you get a lot out of the box, such as read replica, failover, global replication, etc. Whereas if you run those databases in Kubernetes, you are in charge of all those features. Also note that Kubernetes is just one of the container orchestrator and probably one of the most complex one. So depending on your application, you can use ECS or Elastic Container Service or App Runner if needed, as they are much simpler to understand and use than Kubernetes. Next question is, what is Gitops, and can you explain me the end-to-end Kubernetes DevOps flow? This one is super hot right now. In the field, while working with different customers, I'm seeing that Gitops is replacing part of the DevOps, and I predict by the end of either this year or middle of next year, Gitops is going to replace the continuous delivery part of DevOps. And this topic is kind of big. I have a separate tutorial for this with 15,000 views, which shows what is Gitops and how you can use GitHub, Jenkins, and Gitops to deploy into your Kubernetes cluster. I'll play a 30-second sneak peek of what's covered in that video. We have an application running in Kubernetes. That application is saying, hello Docker, and the magic starts happening when you change the code and push it to GitHub. As soon as you commit the changes, a Jenkins job gets submitted automatically, builds a new image, pushes the new image to Docker Hub, changes the deployment file with the latest image ID. The new image automatically gets deployed to the Kubernetes cluster using Gitops, and our application starts pointing to the new pod. I'll give the link of the Kubernetes DevOps video tutorial in the description as well as in the end screen of this video. Please check it out.